Hi, so this video will be on dimension of physical quantities. So physical quantities are quantities that represent the physical thingy lah. So basically your height, your width, your waist, your mass, everything that can be measured physically, right? So kita ada numbers lah normally. So by definition, dimension is defined as a physical nature of a quantity here. So regardless of your unit, contohnya kalau kenapa kita buat dimension ni? Because kita nak categorizekan everything in the same unit. Contohnya, for example, you have your height. Sorry. Kita ada height, waist. Then kita ada width. Okay. So all these three, basically we got to measure them. So they have this different units. For example, we are measuring your height using centimeter, your waist using inch. Then your width, okay, the width of any object in meter, for example. So all these three quantity, these are quantity, height, waist, and width. These are what we call as quantity. All these, they fell into the same category, which is length. So we can represent them as length. So these are the three base quantities that are important for this chapter. So we have here is length. Then the symbol of dimension is L, mass dimension is M, time is T. So for dimension, the unit will be here, the square bracket, right? So how to write dimension? You're gonna first write the square bracket here. Then in between here, you're gonna write down your physical quantity. For example, if you want to find the dimension for the time, so you're gonna write square bracket time, then whatever lah. Okay, then kalau length, you gotta write down length here. So like this lah, we have a square bracket, then the quantity in between, right? So this is so when you write it like this, it indicates that it is well understood that you are given the dimension of mass. Okay, so here kita ada dimensions of derived quantity. So for example, we have velocity here. Okay, so kalau velocity, so what is the equation for velocity? So V equal to S over T, right? Displacement over time. So the first step is we're trying to find the dimensions of velocity. You gotta put down the square bracket for V. Then displacement gonna turn into the dimension, and also for T. Sorry, the square bracket here. So dimension for displacement is length. So it will be L. For time will be capital T. So we're going to bring the time upwards, right? So you guys learned it in high school already. So LT -1. So here, once you convert the physical quantity into dimension, you are not allowed to use square bracket anymore. You need to use a circle bracket yang macam ni. Okay, so these are 8 examples of derived quantities. So here is stated that number is dimensionless. So for example, you have equation. Contohnya kita ada S equal to half U plus V times T. You gotta find the dimension for S. Okay, kita nak find dimension of S. So kita kena cari dimension for half, dimension for U, V, and dimension for T, right? So this half here is dimensionless, means that after you write down the square bracket, dia akan hilang. What does it mean by it's gone? Now it's S. So kat sini, sorry, yang S ni tak, kita masih lagi square bracket lah, sebab kita nak cari dimension for S, which is the displacement. So here dia akan jadi LT -1 plus LT -1, then times T there, right? So lepas tu jadi apa? Dia akan jadi L plus L. Sebab apa? T -1 dah kali dengan T. Yang ini pun kali dengan T juga. So basically we get rid of T. So the displacement for S bukan L tambah L So this displacement, the dimension of S will be L. Sebab apa kita bukan total macam tu, kita akan tengok individually. Okay. So the next one, kita ada dimension analysis. So whenever people come up with the equation, they gotta check using dimension analysis to ensure that the equation is correct. So basically, dimension analysis is a method used to describe a physical quantity in terms of its base quantity, regardless of the system of unit used. So we don't really look at into the unit they are using. Kita tengok dia punya quantity sahaja. Okay, contohnya we have equation V equal to U plus AT. So we got to prove whether the equation is dimensionally correct or not. So first, this will be equation. So for the equation to be correct, for the equation to be dimensionally correct or homogeneous, kita kena ada yang ini. Left hand side dimension should be equal to right hand side dimension. So kalau kita kata V equal to U plus AT, so first I got to find the dimension for velocity, which is we did it before, LT negative 1. Dimension for U, which is initial velocity, is LT negative 1 as well. Then dimension for AT, the terms at the back. So LT negative 2, this is the term for acceleration, dimension for acceleration. Then T, this one is the dimension for time. So we get the LT negative 1. As the dimension for V is equal to dimension for U equal to dimensions of AT, therefore the equation is homogeneous and dimensionally correct. If the dimension is not the same, tak boleh lah. Sama juga bila kita buat equation. Contohnya, kalau kita nak kira kan, kita nak V equals to U plus AT. For us to be able to use this equation, you got to make sure that unit U akan sama dengan unit V akan sama dengan unit AT ni. Barulah equation kita legit. Okay. So in other words, from the dimension, we can also determine the unit. But it's just SI unit lah. So kalau kita tengok dekat sini, dimension for V is LT negative 1. So L represent the length. So what is the SI unit for length? So which is meter. Okay. SI unit for T, which is time, is S. So it's negative 1. So means that unit for V, final velocity, is ms negative 1. Okay.